Okay, welcome back Science 9. This is our second lesson in Unit D, Electrical Principle and Technologies. We are going to learn about the current, voltage, and electric energy. Just basics as a start. No formulas are involved. Before I get things started, have you heard about electric eel that resides in Amazon forest in Brazil? Electric eel, basically they hunt or fight against their predator or human who hunt by rubbing their main organ to the hunter's organ. They produces electricity and complete the circuit. Electric eel produces electricity in a special organ that is located in the organ close to the tail. Let's recall a little bit. In order for electrons to go from one place to another, we need some kind of attraction, which is done by positive end. This is a little recalling. Opposite attract. The tail contains thousands of modified muscle cells called electroplates, and those electroplates, by doing rubbing action, they can generate enough of energy to make electron jump from one side to another side, which is very similar as what we learn in static electricity. However, imagine that is happening between cells, not from simple one object to another. Of course, when you look at one muscle cell at a time, it's not much of electricity. In fact, it's about 150 millivolt. If you think about Pokemon, 1000-volt, millivolt, it is very, very tiny amount. Each electroplate produces a small amount of electricity. However, once it's all gathered around as a muscle bundle or muscle fiber, then the amount of electricity will get way stronger. So the electric charge will stun the eel's prey so that the toothless eel can swallow or eat its prey. That's how they hunt. But the charging part is significant. So let's say you will see in a GIF image, I want you to think about the hunter's organ that is starting from the tail all the way to the main body part of the eel. That is a big or long distance, if you will. Imagine this is a source of energy, such like battery, and you have alligator clip. So if I give a little bit of analogy, positive and negative end, and we have cord attached, imagine this situation that you see is basically what this hunter's organ have. What this electric eel need to do now is connecting a human from one end to another end to complete the circuit. As soon as this complete a circuit, if the completing circuit's happening, then electron will go through like a good conductor. And if you think about, first of all, water with bunch of minerals and ions, they're a good conductor. Plus, human body is also a good conductor also. So I prepared two GIF images. I want you to observe one on the left and one on the right. One on the left is a glove that mimics alligators, and it has a bunch of LED lights so that it can detect its electricity. One on the right is human arm that has LED inside. So I want you to look at how electricity is being detected in both of the gloves. If you look at it, when you see, I'm going to start with alligator, just in the water with no contact. This situation, there's no light. Which makes sense because yes, water has ions, water has minerals, but electrons cannot jump from one distance to another like a shooting gun. We need some kind of contact. So if you look at the afterward portion, where you will start to see a little light, is when you have a Hunter's organ actually touch from abdominal part to lower part of its organ. This section is where electricity is being discharged by completing a circuit. If you look at human arm, it's even more powerful because the abdominal section is located at the upper part of forearm, close to the elbow in fact. And if you go closer to the tail, which is near the wrist and hand portion, can you see that the length, the contacting length is way more, and thus more completed circuits, thus electrons can flow way more freely, and that's why we start to have way more electric energy that go through the arm on the right side. The light intensity is way more stronger. This is an example of how connecting a circuit is a must condition to make electron flow. Without a connected circuit, we cannot produce any type of electric energy, which means good luck from your power plant to your house. The whole electrical energy will be useless even with slight damage in the circuit, or I like to say gap in the circuit. All right, let's look at this tragic situation that I took out from YouTube and the analysis from Google. This shocking happened when an indigenous tribe in Amazon was hunting for fish and they triggered the wrong species in this situation, which is electric eel. So let's look at the picture on the top part first, A. As you may notice, there is no contact. In fact, if you think about how we need to conduct electricity, like I mentioned, we need to have a complete circuit, which means just like a battery with the wire, we need to have a circuit. Right now, we don't have any contact. But now, if you look at the second picture, eel jump up to the abdominal part of a human, and as soon as that happens, we have one end connected. The thing is this though, that means we are connected only this end over here, the one with the head. Now, the zapping part happen, or have to happen, as soon as the lower part of the hunter's organ is connected. And as you can see, the complete shock image over here, you may notice the whole eel has attached to the left part of the leg, and that completed the whole circuit. And the reason that this hunter could not move is because one of the very first symptom of electric shock is a nerve damage. You cannot move your muscle freely because your electric signal inside of your body was basically screwed up. That's why. Okay, let's look at our GIF image first. As you can see, on the right side, we have a flow of electron happen. In fact, this blue line is where electron can go from battery to, in this case, you will know the symbol, lamp, and through the switch. But here's something that I want you to focus on. The flow of electron only occurs from one end to another end as long as the switch is closed. I mean, if you think about any single type of electric devices, that makes sense. We have safety, and when it comes to house situation, we have our switch for everything, including the light to heater, you name it. When it comes to the security situation in your basement, there is a breaker also, where if there's excess amount of electron passing, then it will automatically break. That's what the breaker is. Now, the steady flow of charged particle, we will call it as current from now on. Like the water. Like flowing water. And this steady flow of electrons is needed to operate any type of electrical devices because flowing electron basically means it generates energy. So in last slide, I was talking about the fact that electron flow, from now on, we're going to call electric current. And electric current is must needed components in electricity or any type of electrical businesses, including your devices, including power plant business, anything, industrial process that use electricity, you name it. We need electron flows because the current generates electricity. So what are the stuff that is required? First of all, we need energy source. If you think about energy source in your small electronic devices, batteries or battery is a good source that you can think of. When it comes to power plant situation, energy source is a little different. It can be fossil fuel, it can be hydroelectric, so dam if you will, and list can go on and on and on. I'm going to erase this a little bit so that you guys can see. On the other hand, what also we need to consider is, like I mentioned, completed circuit or path with no gap, with no damage in between. Imagine there is a physical cut happen in this wire, then the thing is we cannot operate any single components that is attached to the circuit because of this damaged site. This is one of the reasons why when it comes to internet outage or any type of electric blackout situation, the company like AppCore need to go through every single site so that they can find the damage and they can fix the damage, which is possibly a circuit part or transformer in residential area. There are two things that we need to go through. One that is known as conventional flow notation and the actual electron flow notation. This is historically came out first, the one that's known as conventional flow. Long story short, conventional flow go from positive to, so I'm going to say from positive to negative. Out of the bat, I'm going to tell you right now, this is a wrong method. However, some people still use conventional flow notation just because historically, that's what people believe that electron will flow. However, in fact, it is opposite. Electric charge move from positive that people thought once as a surplus side of the battery to the negative, which is deficiency side. This is very mathematical situation. If you think about positive means you add it, so you have more, negative means absent. That simple thinking is what people have. But let's think about our unit B. Is negative charge ion actually absent of electron? Not really. If you think about, let's say, calcium atom. But calcium atom can turn out to be calcium ion with 2 positive. If you think about this 2 positive notation from our previous unit, that's a fancy way of saying 2 electrons are absent. Because the number of proton, number of electron, proton number is more. That's why we are putting that positive. Same thing goes to negative. Let's say chlorine has 1 negative. That's a fancy way of saying Cl minus charge as an ion means 1 electron gained. After Thomson, if you remember who that was, the person who used cathode ray tube to discover there is positive charge and negative charge inside of an atom. In any case, electron flow notation is what you need to consider. This is an actual situation. Electrons actually move from negative end and go toward positive end. And this is actual theory that we accept even nowadays, because negative means we have extra electron. That's why we put the notation of negative. On the other hand, positive that means we are absent of electrons, so there are more protons, thus we use positive as notation, and that part is absence of electrons. And this is the correct notation, except scientists discovered that way after. So in the end, you will see a situation where some curriculum in US, they use conventional notation, but in Canadian method, we are using this number 2 electron flow notation just because that's more realistic. That's what electrons try to behave. If you again wonder why go from negative to positive, well, remember, positive, negative, they're oppositely charged, so they love each other. Except proton cannot move. They are part of the nucleus. Electron can move. That's why electrons are the one that move instead of protons. So you may wonder, which one is correct? I personally believe electron flow is the correct one, but again, it is widely accepted. The concept of electricity was basically established before the discovery of electron. Therefore, it was believed that the passage of current is due to flow of positive charge back then. That's the only reason why conventional flow of current is being discussed. After the discovery of electron, I'm going to put our good old Thomson. I want you to recall Thomson's experiment in Unit B. He's the one that proposed chocolate chip cookie model. In atom, something like that. It was observed that electrons are in fact subatomic particles that flow in the conductors, and electrons are the one that has a negatively charged, and they are the one that is mobile. And because it's mobile, they will obviously go towards some place that attract them, which is a positive terminal of the source. Therefore, actual direction should be always negative to positive. I'll put quite a lot of emphasis on that one. But I want you to know, like I said, both way, conventional versus electron flow. From now on, however, I'm going to use electron flow method to describe most of the phenomena from now on, whenever there is any example. We are going to use some of those instruments too, and you need to know what these are. The one that you see in the image in this slide is known as galvanometer. First of all, I want you to look at the units over here. Few things. The one that look like, let me draw better. One that look like small case u with the one end elongated on the left side. This is a Greek letter mu, like Pokemon Mew, MEW, but the unit is micro. It is smaller unit than milli. It's in fact 1,000 difference between micro and milli. A means amperage. This is the one that we're going to use from now on to discuss about any current strength, quantity if you will. A galvanometer is a device for measuring electric. All right, let's talk about galvanometers. So I want you to focus on two things. Number one, did you notice that there's a little weird case U that is written on and the left side goes droopy a little bit? This is Greek letter mu, M-E-W, just like Pokemon. However, when it comes to unit, it's micro. Micro is a smaller level than milli. So for example, if you think about gram, that's a larger unit than milligram, and there's 1,000 differences. And also, there is a micro, which also has 1,000 difference. So if you think about normal unit to micro, it actually have about million difference. I want you to think about that. Why did I explain about the unit first? Is because galvanometer, I just wanted to tell you that it is a very sensitive laboratory instrument that can detect small amount of current, not the big amount of current. If there's a big amount of current, then what's going to happen is, the machine will actually start to have a meltdown, just like how breaker works in your basement. Also, I need to elaborate a few things because I bet not a lot of people are familiar with the setup. The black end, whenever you're dealing with electric devices, always have to connect to negative terminal or negative source. So imagine you're connecting a certain battery. You need to connect negative end to the black color using alligator clip. When it comes to red one, you may guess it, connect to positive end. So that the whole circuit will be connected. That's my horrible way of drawing battery. You know what? I can do a little better. There you go. Something like that. Depends on the strength of it. Once this circuit is completed, then our reader at the middle, 0, will go left and right and determine the strength of it. A current carrying wire creates a magnetic field which will deflect a compass needle, and that is why we have this install magnet and how electron carrying wires can actually generate magnetism too. But this phenomena that I like to say electromagnetism, we're gonna explore that way more detail in chapter 2 or 3. In previous slides, we saw a unit. I'm gonna draw a little better. That looked like this. This U part, we know it's micro. What is that A? A is from now on, we're gonna, if you learned it and if you knew it already, that's good. If you haven't, it's a unit for electric current. So how much flow that is happening. So imagine you go to the river. If there's a very, very, very strong current going on in that river that you shouldn't swim because you're going to sweep out or sweep down to the below part of the river, that means you're going to have a high ampere if it's electron analogy. On the other hand, if it has really slow rate inside of the river, then lower number. So a higher number means obviously more current. Lower number means less current. The rate at which an electric current flow is measured in ampere. We call AMP or big letter A. Most electrical devices at home have a current less than 15 amp. A generating station produces thousands of ampere at a time because it's such a massive macro scale. However, there is a device that makes our high ampere down to lower ampere, and that's sometimes what you see or hear as transformer. Transformer, if you want to know, even though I have a pretty poor drawing skill, in the highway you may see a wooden pillar that carry electron like this. You may notice a little drum barrel looking structure that is attached right next to it. This is transformer. In the residential area, it looked like a square cube structure between house to house. Transformer basically controls the level electric energy. It brings it down to a safe level to house. It brings up when it comes to industrial area or vice versa. As I mentioned, ampere, which is electric current. Current means electron has to move constantly. Third is very dynamic. To control that, we use switch, because if there's a switch, then you have a completed circuit. That means electrons can move. On the other hand, if it's switched off, even though there's a source over here, you cannot let electron move. Thus, it becomes stationary. Electrical energy is transferred from one place through another place using conductor. Most of the time we use metal wire. The most common one is copper because it's cheap and good conductor with less resistance. However, you may know that or hear about the fact that gold is the best conductor, but with obvious reason we are not using it because it's expensive. And a circuit is a path that controls the flow of electrons. Okay, the way that electricity is being delivered, like I mentioned, is from our source, in this case power plant, that has high voltage, high ampere, high current if you will. But when it comes to safe usage in residential area, we need to have a wire that is carried, and within these we have transformer that bring the voltage and ampere down. That is how every single country does and utilize electric energy safely in home environment. If you go other way around, go to, for example, industrial area, so there's like manufacturing plants, something like that, then sometimes they raise up the voltage or leave the voltage as the same level, just because they need a lot. Electrical energy is carried by charged particle, electron if you will. Voltage is measured of how much electrical energy each particle carries. If I use the analogy of voltage and current, this is what I like to say. Current is how much things are flow rate. So if you change the size of the hoses into bigger circumference to smaller circumference, you will definitely have more current if the circumference is bigger compared to the less one. Voltage, the one that we're learning right now, is more about pressure. So how much strength and energy is our discussion in here. The higher the voltage, the greater potential energy. Potential energy, the reason why I call potential energy is because it has a potential to do work. So if you think about this way, less voltage, that means less potential energy, which means we can do useful work less. On the other hand, if there's a higher voltage, then you naturally have higher potential energy, which means it will naturally have more work utilized by that potential energy, even though there's some waste energy in real life, like heat and those kind of things. Voltage is sometimes known as potential difference, and I'm gonna connect that analogy of pressure in here. If you think about pressure, it's always go high pressure to low pressure, something like that. Electricity work exact same way, high source to low source. If you think about gravity, exact same thing. Gravitational energy is known as gravitational potential energy because let's think about a dam. And there's a gate. If you think about dam, you will know that if I open up the gate over here, water will go from higher ground to low ground. And we're using gravitational potential energy because gravity always try to make things come from higher to lower or closer to the surface level. That's why even if you jump, you're gonna guarantee coming back to your surface. You're not a Superman, you cannot just go off. Now, if you think about hydroelectric plant, which is the one that use dam, while that water traveling higher ground to lower ground, we have a device over here that actually generate electricity by turning the turbine. Think about a motor, except it's run by water, something like that. So in this case, dam use gravitational potential energy because it has enough useful work to do to generate electricity. So whenever you hear any potential energy from now on, just consider that, oh, okay, that means whatever that potential energy have a possibility to turning into useful work to generate some kind of other energy like electricity. And like I said, electric energy is just like gravitational energy, except we have to think about one fact: opposite charge attract. So if something is higher potential, they are located further away from different charge as a start. But once it is released, just like a spring, have you played pinball? Hopefully you do. Pinball have a little bit of spring and then it's compressed, and after that it is released. That's how pinballs start. And imagine this ball will go speed up to the other side. That is a little theory behind it. Fortunately, you don't need to know that detail when it comes to electric potential. Just know that voltage is sometimes called potential difference because we have high potential to low potential area, which is same charge area or similar charge as a start, then opposite charge later. So the energy delivered by a flow of charged particles basically equal to the voltage times the total charge of electron. In fancy way of saying, If I have high voltage, just consider high energy, which means I can do a lot of work, useful work, to run something. If it's blender, how much blender will spin? Something like that. If I have less voltage, less energy, that means less work. I want you to think about that as a dam analogy in hydroelectric plant. Imagine you have a lot of water on the higher ground versus not much of water in the lower ground. The one who discovered the relationship between potential difference and energy is done by physicist Alessandro Volta. Like the word suggests, yes, a volt unit of the potential difference came from him. He basically invented the first battery by having positive end, negative end, and stack of sources, just like a battery cells. That's how the first battery worked and operate a little bit. It was quite faulty, just one demonstration and a little bit, then it was ineffective. As I mentioned, potential difference, I always look at the dam and hydroelectric plant and turbine in between. Voltage in everyday devices are fairly low, but industrial machinery operate at 600 voltage, so they need powering up transformer instead of powering down transformer in residential area. Just like galvanometer, in order to measure voltage, we use, like the word suggests, voltmeters. Like I mentioned in previous one, just know that black end, negative end, positive end for red, and we need to connect those using alligator clip to the sources. If you are working as an electrician in future, this is a portable version that you can use. And like I said, red to positive, black to negative. That is it, ladies and gentlemen. Today's homework is basically doing all the science log activities that I put, or questions if you will, inside of the booklet. And when it comes to next class, we're going to start by going through those. And always remember, some of them I'm going to use it for future exit slip questions. And who knows, possibly the unit test also.